Okay, so here I'm going to solve the rest of practice exam number 4. Here's question number 9. To do this, we're going to have to find this part x. Here, let me change the color so you can see it better. We're going to call this x, and we got to find that. Since this is a right triangle, see the right angle right there? We can just use trigonometry, a right triangle trigonometry. SOHCAHTOA. I'm getting a little scribbly here. SOHCAHTOA. You don't have to use law of sines or law of cosines, although you could do this problem with law of sines also. I think it'll be easier to just say, look, 37 degrees is the angle in this little triangle first, and this is opposite over adjacent. That's tangent, right? Opposite over adjacent. So tangent of 37 degrees is opposite x over adjacent 60. So now we can solve that equation for x, multiply both sides by 60. So x equals 60 tangent 37. Let me get that on my calculator here. Make sure you're in degree mode. I'm getting 45.21. Well, it looks like all the answers have 2 places, so I better do a little bit more than 2 because I still have more work to do. So I'll go 2, 1, 3, 2, 4. Always use more accuracy than you need in the end when you're still in the middle of a problem. Okay, so I got x. So this x over here, erase what I did in the triangle, is 3, this part right here is 45.21324. That's from there to there. Okay. Well, you know what I mean. Okay, so now look at the big triangle. The big triangle is also a right triangle, and this big angle here is 48. So same kind of thing. We can say tangent of 48 is opposite that whole side over adjacent. So what's that whole side? A, that's A, plus the 45.21324 over adjacent 60. So we can use this to solve for the little a. How do we solve for the little a? Well, kind of like last time, multiply by 60. Boom, that cancels. Then over here my calculator tells me 60 times tangent 48. I'm getting 66.63675 equals little a. These are gone now. So little a plus 45.21324. So last step, subtract the 45.21324. Subtract 45.21324. And little a equals 21.42. There it is, answer D. All right, let's go on to number 10. Remember what I said, that one of these two, 9 or 10, will be on the exam. Exactly the same, except the numbers will be changed, but the picture will be identical. Only one of them, not both. One of them identically on the exam, just with the numbers changed, picture identical. Okay, how do we do this one? Well, we're going to have to find this angle here first off. That angle there, call it angle C or whatever. This angle here, so 52 plus angle C must be 180, right? Because they make the top of a straight line, right? This amount plus this amount together make a 180 degree rotation. So solve for C. Oops. Let's try 52 from both. 128. So C is 128 degrees. Angle C is 128. Right there. And if we know that, then we can find the angle at the top up here, whatever you want to call that, because the triangle must hold 180. So 128 plus 28, what's that? 140, 156. So 180 minus 156 leaves 24 degrees, yeah. So this one up here must be 24 degrees. Okay. Now, why am I doing all that? Because now I have an angle and the side across from it. So I can do law of sines, and I'm trying to find 28 and the side across from it, a. I want to find little a. So start with little a over the sine of 28 is, I put the sign on the bottom, so it would be 2.3 over the sine of 24. See that? Diagonal, diagonal, cross multiply. A sine 24 degrees is 2.3 sine 28 degrees. Divide by the sine of 24 degrees. Little a equals, let's say 2.3 times sine 28 divided by sine 24. I'm getting 2.65. So there it is, answer C. All right, let's move on. All right, number 13. Two forces. Okay, this is a harder problem. So here we go. So force 1 is 60 pounds. Force 2 is 70. The direction of force 1 is north 40 degrees east. So let's find that first off. So north, and then 40 degrees. So 40 degrees east. So here's force 1 is north, but 40 degrees east of north. So what is that actual angle as we would give it a bearing? That's, from 0 degrees, that's up 50. So force 1 is a bearing of 50 degrees. What about force 2? Force 2 is north 40 degrees west. So north, again, straight up, and then 40 degrees west to the west. That's force 2. And so what would be that angle? Starting from 0, how would you get to that angle? Well, this is 90 straight up and 40 more. So force 2 is 90 plus 40, 130 degrees. So force 2 is really a heading of 130 degrees. It's 90 straight up plus 40 more. So it's 130 degrees. So we have force 1 and we have force 2. So let's be clear now. So force 1 is a 50 degrees force and it's 60 pounds. And that means, how do you write that? You say force 1 is 60, not sine, but cosine. You start with cosine, right? Cosine 50 degrees I plus 60 sine 50 degrees J. And then force 2, which is what? It's at an angle of 130 degrees, and its force 2 is 70 pounds. So then, how do we write force 2? It is 70 cosine 130I plus 70 sine 130J. So you're good with that? Once we know the angle and the amount of a force, it's just the amount times the cosine for I, the amount times the sine for J. Same thing here. Once you have the actual angle for force 2, meaning from 0 degrees, right? It's 130 to that spot. And the amount, 70 pounds, is amount times cosine of that angle I, and amount times sine of that angle J. So we got force 1, we got force 2. Now, we can simply calculate those numbers, add them together, and we'll get the resultant force. So that's going to be some work. Let's go to a fresh screen on that. Okay, so here we go. So I'm going to say force 1 is 60 cosine 40 degrees I plus 60 sine 40 degrees J. Let's get the numbers on that. So that's, now they want 2 decimals in the answer, so I'm going to go like 4. 45.9627 I plus 60 sine 38.5673 J. Force 2 going to be 70 cosine of 130i plus 70 sine 130j. So then, show force 2, using the calculator, 70 times cosine 130, I'm getting negative 44.9951 I and plus 53.6261 J. Okay, got force 1, force 2, add them together to get the overall resultant. So the result of two forces, the resultant force, is you add them together. So we're going to add together this number and this number. It's actually subtraction because it's negative. I'm getting 0.9676 I, and then plus, and then this number, and this number. I'm getting 92.1904 J. So the magnitude, so there's the actual resultant force. So I had to figure the magnitude. Well, the magnitude is the square root of the first number squared plus the second number squared, right? The Pythagorean theorem, square root of a squared plus b squared. So let's do that in our calculator, plus I'm getting 92.92 195, so I'd say 20. 195, 92.195, so 92.20. Okay, so we got that for A. Well, we got that for the force. And now we need to know the direction. So how do we find the actual direction? Well, remember the direction, theta, is inverse tangent of the positive j over the positive I. And then you put it in whatever quadrant. That gives you a quadrant 1 answer. Then you got to put it in whatever quadrant it's really in. So theta is inverse. I'm kind of running out of room here. Theta is inverse tangent of positive j. That'd be this, 92.1904, over the positive I, this, 0.9676. Okay, so 92.1904 divided by 0.9676, and inverse tangent of that, I'm getting 89.4 degrees. 89.4 degrees. And I don't need to adjust that because it's already in quadrant 1, right? This force, go over here, see how it's to the right and it's up, both positive, over right, up. So the force, the resultant force vector is in quadrant 1. If it was in quadrant 2 or 3 or something like that, then I would need to adjust the angle because that would just be the reference angle. Then I would need to turn it into a quadrant 2 angle or 3 or 4 or whatever as the case may be. But that's already a quadrant 1 answer, so that's my answer, 89.4. So it looks like D is the answer on that. Okay, let's keep going on. Was that too quick? Did you get that? So the answer was D on that one. All right. Okay, so this one, they're giving me the vector and they're giving me the angle. So you know how to do that. It's again the vector times the cosine of the angle A plus the vector, magnitude of the vector, times the sine of the angle J. So 7 cos 225I plus 7 sine 225j. Now normally we can use our calculator, but you can tell by this that they're using the exact answers from the unit circle. So have the unit circle for sure on your 3x5 card. Find 225 degrees, which is right there. No, it's not. Which is right there. 225 degrees is right there. And if you look on your, that's middle. So that's back root 2 over 2, down root 2 over 2, both negative. So this is 7 times negative root 2 over 2, I, plus 7 times negative root 2 over 2, j. So 7 over 1 goes to the top, so negative 7 root 2 over 2, I. Negative 7 over 1 goes to the top, 7 root 2 over 2j. So there we go. Which one is that? Both negative 7 root 2 over 2. So it looks like B on number 14. Very good. All right, number 15 now. So number 15, find a unit vector. To find a unit vector, for any vector, you just take V and divide it by the magnitude of itself. That makes it a length of 1. When you divide it by its own length, you make its length 1. So what's the magnitude of vector V? Remember, that's the square root of a squared plus b squared. So it's minus, that's a 3 there, I'm scribbling, plus 1 squared. So square root of 9 plus 1, square root of 10. So just take vector V and divide by square root of 10. So you take the original minus 3i divided by root 10, and then the 1j and divided by root 10. So there we go. That's D, right? Minus 3 plus 1. Yep, D, we got it. All right. Next, it says on 16, or I'll go to fresh screen. All right, so here's 16. Find magnitude, so double bar magnitude, of V minus U. So we've got to take the V vector right there minus the U vector. So what's that? So this minus sign distributes, huh? So minus 6i minus 16j plus 2i minus 4j, which is minus 6i plus 2i minus 4i minus 16 minus 4 is minus 20j. Magnitude is the square root of minus 4 squared plus minus 20 squared, and that's the square root of 16 plus 400. Is the square root of 416. I don't know about simplifying square root of 416. Use your calculator. See what it divides by. Divided by 2, it's 2 times 208, which is 2 times 104, which is 2 times 52, which is 2 times 26, which is 2 times 13. So you break that thing all the way down. Every 2 2's sends out a 2. You remember this from algebra, how to simplify? So 2 2's sends out a 2 to the front. 2 more 2's sends out another 2 to the front. They're gone, they're gone. And then you're left with 2 and 13. There's not 2 more 2's or 2 more 13's. So that stuff stays inside. 2 times 13 stays inside, right? Every 2 2's inside sends 1 outside. So that's 4 outside. Root 26 is that one? Oh, it's none of the above. That's tricky. All right, let's go to 17. So number 17, vector V from P1 to P2. So basically you just subtract them. The vector V is going to be 0.2 minus 0.1. So 0.2 being minus 3 minus 6. I can turn it into a vector. So it's going to be P2 vector, which is minus 3i minus 6j, minus the P1 vector, which is 1i plus 5j, P2 minus P1. So that minus sign distributes. Minus 3i minus 6j minus 1i minus 5j. Minus 3i minus, so it's minus 4i minus 11j. C on number 17. Yep, that makes sense because that's from P1 to P2. So from P1 to P2. So that's why you take P2 minus P1. Yeah, because we're going from point 1 was over 1 up 5. and point 2 was back 3, down 6. This was point 1. This was point 2. We're going from P1 to P2. So I took vector 2's coordinates, P2's coordinates minus vector 1's coordinates. I always take the end minus the start. I took the end minus the start. All right, let's go into 18. So number 18. Okay, so use the dot product to determine whether they're parallel, orthogonal, or neither. So let's take vector, oh, you know what I would do actually on this one? I wouldn't even, well, we can start to dot it if you want, but I can tell they're parallel already. Let's go ahead and dot it. So remember the dot product, you take 3i plus 2j dotted with 6i plus 4j. Dot product is you just multiply the I with the I, 3 times 6, add the j with the j. And you remove the i's and the j's. No more i's and j's. Just multiply the numbers in front of I with I and the numbers in front of j with j and add them up. 18 and 8, what's that, 26? So that's not 0, 0. Yeah, it's not 0, so it's not orthogonal. Remember, they're orthogonal. They're perpendicular. In other words, if that dot product comes out 0. So they're not orthogonal. Now, are they parallel? Yeah, they are. Look at them on a picture. This is over 3 up 2. And this one's over 6. This one's over 3 up 2. This one's over 6 up 4. See, they're on the same line. They're parallel, right? This one's just double that one, so parallel. Just by looking, you can tell they're parallel. Let's keep moving. Okay, number 19. Let me back up 1 second. So 18 was parallel and was A, right. Okay, number 19 now. 19, they want me to find the angle between. Well, there's a formula that says the angle between any two vectors is the inverse cosine of the two vectors, their dot product over the magnitude of the first one times the magnitude of the second one. So it's the dot product over the magnitudes, inverse cosine of the dot product over the magnitudes. So it's going to be the inverse cosine of the dot product. Now how do you do that? Going to take the 2j, that really means 0i plus 2j. That one we're going to dot with the other one, which is 8i minus 3j over the magnitude of u, which is the square root of 0 squared plus 2 squared, square root of a squared plus b squared, times the square root of the other one, 8 squared plus negative 3 squared. Inverse cosine. Okay, when you do the dot product on the top up there, it's the I times I, 0 times 8, plus 2 times negative 3. Over on the bottom, we got what's that, the square root of 4 times the square root of, I don't know, 64 plus 9, 73. This is 64 and 9, 73. So there we go. So we have the inverse cosine of whatever that is, negative 6 over square root of 4, that's 2 root 73. Well, you can go type, don't have to keep simplifying. Just type it into your calculator right now. Inverse cosine of what's in the parentheses there. I'm getting 110.6 degrees. B. Answer B on number 19. Let's keep going. Number 20. So number 20. Want me to dot, so u, vector u, minus 3i plus 6j, dotted with v plus w. So v minus 9a I minus 10j plus vector w, which is minus 3i plus 2j. So v plus w, and here's u. So we'll leave the u over here for a minute. Keep the dot in the middle. This is the dot product. And minus 9i minus 3i is minus 12i, minus 10j plus 2j is minus 8j. And now dot them. How do you dot? Remember, dot is a special thing, the I with the I and the j with the j. Negative 3 times negative 12 plus 6 times negative 8. And you drop the I and the j. When you do the dot product, you just multiply I with I, j with j, add them up, and drop the I and the j. So you get positive 36 minus 48. So minus 12 C on 20. So C on 20. Let's go on to our last one, number 21. Okay. So this wants the dot product. So 7i plus 9j dotted with 14i minus 7j. I with I, j with j. So it's just 7 times minus 14 plus 9 times minus 7. So it says minus 98 minus 63. Is it minus 161, it looks like to me? Yep. A, and there it is. We are done.